Okay, next topic we will see is the deadlock. So and blocking as well. Deadlock. So suppose we have transaction 1 and transaction 2, and transaction 1 is dealing with table A and transaction 2 is dealing with table B, and then at the same time, to finish the transaction 1, transaction 1 is requesting for resource from transaction 2 for transaction 2 table access, but at the same time transaction 2 is updating this table, so it cannot release the lock on it, so it has to complete the transactions. And then on the other hand, transaction 2 is also dependent on transaction 1's table 1. So both are doing updates, so it has exclusive lock on their resources or tables, and it's asking for other resources from other transaction, and they will go on a loop or infinite loop unless they are done with it, and then SQL Server seeing this, that they're fighting for this resources in a loop, they will kill or terminate one of the processes. So this is the situation where it calls deadlock. So here is the picture that we can see of a deadlock scenario. So to see the deadlock, we have to see the deadlocks on SQL Server error logs. So here is SQL Server, and then if you see a deadlock, where will you see that? This is error log under agent, okay? And if you expand that current log, okay, so SQL Server error log, you can see it here, and deadlock will appear in this place, okay? And this is based on the date you have logs. There is a specific location for that as well. So to set up the trace, or to see it on the log, you have to enable the trace flag on SQL Server. What it will do, it will using dbcc trace on this statement, it will enable the logging on SQL Server error logs if any deadlock occurs. Okay, so and on the SQL Server properties, okay, startup properties, you need to set it up like that, so that each time SQL Server restarts, it will have this enabled all the time, and whenever deadlock occurs, we will be able to see it on SQL Server logs. Okay, so this is the error sample. You will see like which ID is causing the deadlock, and the resources will be there, or object ID will be there. Based on that, you can find which object is it's trying to read or locking. So speed this, and then object ID will also be there. On the other hand, we have another speed. So this is what we can see, like the process what we talked about, process A and process B, and their resources, and they're locking and requesting for other resources. We can see update statement. Okay. So this is the way we can just read the deadlock, which resource it's occupying. Now, in terms of solution, what we can do, we can enforce the no lock hint when we do that. If it's a read request, if it's update request like this, you need to manage it in such a way so that this situation doesn't occur. So for that, you have to, whenever developers write a query, they should be writing it in a serial manner, not in parallel manner. So first of all, your transaction 1 has to be completed completely, and then once it's done, you need to enable or start transaction 2, so that it doesn't go on interdependent situation and infinite loop or of locks or something like that. So SQL Server locks. So whenever we do some operation, even for select or insert, update, delete, so if a process needs to perform that, so you can understand, if I'm updating a table, so if somebody else want to change at the same time, it will have a conflict. So what it does is, like, when first request comes, it grants the lock, okay, so that on the resource or table, so that nobody can make any other changes. So once he will be done, lock will be released, and other process can take this table and lock it for other activities. So this is the concept of SQL Server locks. Now there are different type of locks. Is like no lock. So if you are selecting a data, you can enforce that I'm selecting the data, but it's not a lock. So anybody else wants to lock it, that process can go ahead and lock it. So that is the way of lock. If somebody wants to do update, so it can exclusively lock the table so that nobody can lock it. Now there are certain level of locks. So whenever you see sp locks on a table, if you run that statement, what will you see? You will see like information similar to this. So what type of lock is that? Okay, schema change. Okay, and then it's on table, lock on database. This is database level lock, this is table level lock. This kind of information, if you run that, you will be able to see it. This is shared schema modification. Lock is on a table. This is shared lock. This is update that's going on, so exclusive lock will be there, or you can enforce exclusive lock on that for other activities. Okay, these are the types. There are several types of locks, and we can read it on books online with this term as well, SQL Server locks or SP_lock. Another concept is blocking. For blocking, as we know that suppose we have a table, and somebody has a lock on the table, and on the other hand, if somebody tries to access the resource, if it's an exclusive lock, this process has to wait unless this is done. So this situation is called blocking. So time to time we will be able to see like a production team may request, could you please check if my process is getting blocked by others. So how do you check that? If you run sp-who to active on SQL Server, you will be able to see that this transaction is going on, and your others transaction is waiting for to be free of this resource. As you can see, this is blocked, so it has to wait, and we will see the scenario by running this statement. So we can check right now. So here you can see, and all the active processes will be after 50. So we don't have any block, but this is blocked by. So if there are any blocks, so for instance, my process is 59. If somebody is blocking this, it will come here with his speed. And what you need to do, you need to run dbcc input buffer, and then you put the ID name 59 whatever to see exactly what is blocking it. So we will be able to check that. This is already terminated, so it's not there. So you can write whatever speed you identify. So I will just put it in there. Speed ID, you will put it there. So that is about blocking. So next topic we have query execution plan. When a query runs in SQL Server, so it has a plan like how it will execute the query, because query has different part. It has sort, it has pulling information, all other activities are there, and this execution plan, and we will be able to see what is the plan for the query execution. So this will represent like how the query will be executed. Okay, or which implies like before you run a query, you will be able to see how it will be executed, or if it's already executed, you will be able to see how it was executed. So all this information we will be able to see. Now, talking about execution plan, this is the execution plan. We can see how we will be able to see on SQL Server query window. So what we will do, you can select that, okay, and before you run it, even you can put display estimated execution time, execution plan, and this is the plan you can see, and this is exactly like how it will be after the execution. Okay, so if you enable this include actual execution plan, and if you execute that, okay, you will be able to see the execution plan as well. Okay, now suppose you have a query there. I think we just wrote it somewhere. So here there is a query on AdventureWorks 2012 database. Here you can see how to see the execution plan. So what I've done is like enable the execution plan and then execute it, and here okay, include actual execution plan. Here you can see the execution plan. Here it seek index seek is the cluster index scan is there. We will try to understand what this means and what we need to do for each execution plan. So here we can see thin line and thick line. So thin line means the amount of data it's returning to this. Okay, so we can see here there is a thick line, so this is processing huge amount of data and returning it to this. Okay, so when you read it, the logic goes from left to right, and that data gets returned from right to left. So that is the idea for that. So if you hover here, if you take your mouse here, you'll be able to see that it's a physical operation in index seek or in whatever is there, and then on the bottom you can see estimated number of execution. Okay, and then number of return row, number of rows it's processing, estimated row in bytes, 11 bytes. Okay, all this information, and scanning particular range on the top line, scanning particular range of rows from a non-clustered index. Oh, okay, so it's it has index seek, which is better, and it's not reading all the index pages. So that is optimal process. On the other hand, we can see another one, that is index scan. So it's reading index pages to retrieve the information, and you can see the thick data is there, so a lot of processing. It has cost, it has to remove for optimized performance. So for this index execution plan, couple of things are there we need to look. So we will see one by one. First of all, you will target the thick lines. Okay, thin, if it's thin line, so processing is low, so you don't need to be worried. Or if you see the value, cost value is very low, you can eliminate that. But if the cost is high and doing index scan, and then it's a thick line, obviously you have to have some plan to eliminate this. And scanning, scanning means like the index, we saw the index chapter, so all the index pages, it will go just like a book, you can say, like entire index it will read. On the end you have indexes, so in terms of book, each and every index you will read. On the other hand, if you know that you are looking with a word, like specific word, it will scan, and you can skip all the A's and jump on Z directly, or H directly, so which will be faster. So if you that concept will be called as seek. So thick lines is the main target, and then lookup, we already discussed in index what is bookmark lookup or key lookup. So if this is the lookup is there, what you need to do, you need to add non-clustered index to eliminate that, and you will see your select statement, and you need to target like your anything on select, or anything on your group by or where clause, and you need to add that on non-clustered index to eliminate that. Clustered index scan, you need to make sure you understand the query, and maybe where that is also can be eliminated with non-clustered index, and you will be able to see if you see query execution plan, there can be a recommendation here. Okay, if there is any recommendation on execution plan, sometimes you will see the recommendation plan, recommendation index recommendation, and you can apply that. But if you don't see it, you need to understand, like, and do trial and error basis, like, okay, let's put you need to check existing index, and if any attribute is there that doesn't have index, add it on non-clustered index. Okay, or try to make covering index. Covering index means you have a where clause, you want to put some index there where you are using, like name is there, you need to check if already any index is there, or even if it's there, whatever attributes are there, you're dealing with all these attributes, you can create a non-clustered index to eliminate this bookmark lookup. Or scanning. Spool represents also lack of indexes. Okay, or you can see it if it has it's dealing with repeated rows. So one attribute has repeated rows, and it's returning here repeated rows. So you may need to check the query where it's doing this, and you may need to use a distinct operation there to eliminate uh, the repeated rows. Um, so you can look for that scope, or you can use index and just eliminate that. Um, you may see sort, okay, and sort has cost. So if you see sort, you may need to check if there is any order by on your query. That is not necessary. Okay, if there are any unnecessary order by clause, you can do the operation, and maybe later on you can just select, or maybe sometimes order by is not required even on the query. So when you are doing joins of two tables, sometimes you will see hash join, and that is an expensive join. Uh, um, so you will try to eliminate that, and for that also, one thing you can do is, like, you can use tuning advisor to eliminate that, or you need to review the query to see why it's causing this hash match or hash join. Um, so um, there can be a way around, like, to see sometimes people use the join in a different manner, or they have more expensive query in inner loops. So you need to see the logic how this has been developed, and based on that you can advise if there are any better way the query can be written. Now, seeing the tuning advisor, how we can check, like, what is the such a suggestion from SQL Server. So analyze the query on database tuning wizard. You can select that way, okay, and then DB Adventure works, okay, and then you select anything you need to select on that, or tuning options you have. You can change all this, and then once you're done with it, you'll start analyzing this, and it will give you as suggestions. So here we can see that there is a target of recommendation. If we create that, the estimated improvement will be by 60%, 63%. Okay, and it will help you if you apply that. Then it will help you optimizing the query. You can see the suggested query here, whatever index is required. So copy on clipboard, this option is there to see the query advisor. So this is the way you can even check like what can be the suggestions. One more time on how you can see it again. So so suppose you have this query, you can even select, right click on that, and then analyze the query on tuning advisor. You can go from there, or you can launch it from query, and then analyze query in tuning advisor. So let's review what we studied in this lecture 12. It's partitioning we studied, and then index fill factor, statistics update, creating statistics, graphical query execution plan, database tuning wizard, log, block, and deadlock. So these are very important topic for DBA and DBA for a DBA role, these tasks will be there day-to-day basis. Thank you.